Right, Assalamualaikum and good day. This is the recorded version of post-lab for SK015 experiment 2, which is on acid-base titration, in which you have to determine finally the hydrochloric acid solution. Okay, let's begin with part A, preparation of standard solution of oxalic acid. As for experimental data, the exact mass of hydrated oxalic acid obtained was 3.0038 grams, in which this is the exact mass obtained from the reading of analytical balance. But remember, this oxalic acid is hydrated, in which the formula is H2C2O4.2H2O. But don't worry, this H2O will dissolve in the distilled water and finally will give you the solution of oxalic acid just like the normal solution, right? So how do we calculate the number of moles of hydrated oxalic acid? As usual, take the mass divided by the molar mass. If you calculate the molar mass, it will be 126 gram per mole, and that will give you the number of mole of hydrated oxalic acid. Okay, and the molarity of oxalic acid is calculated just like the formula, in which the formula is the number of mole of solute and H2C2O4 over the volume of solution. So whatever the number of mole of H2C2O4 obtained from the previous part, you substitute here, okay, say that this is X, this is also X, and the volume of solution, is, okay, remember, in the preparation, you add distilled water until the graduation mark, in which it is 250 ml of solution. Therefore, the volume of solution here in liter is 0.25, and that enable you to calculate the molarity of oxalic acid. Knowing the molarity of oxalic acid, we can now use it to standardize our sodium hydroxide solution. By standardizing, this means we want to actually to determine the exact molarity of sodium hydroxide. 0.2 molar is not enough. We want the exact concentration, normally up to 4 decimal places. Yeah. Okay. Now, these are the actual readings. The readings obtained by my ex-student. Look at the final reading, 24.95, and in which she started with 0.2. Remember what I mentioned about not having to have the initial burette reading at 0. 0.00 is not needed. Basically, you're going to waste your time, because you always use your calculator to subtract the initial reading from your final reading. Jadi tak payahlah sampai kosong. Okay. Now, whatever reading that you get, just record it. That's it. And the volume of NaOH used was 24.75, and this is the gross reading. Yeah. What do I mean by gross? Gross means it's just an estimate of how much of titrant we need. In this case, the titrant is NaOH. So basically, we know we need around 24 and should be less than 24, because normally for gross reading, we do it at a very fast rate, and the color of the endpoint is not pale pink. Most of the time it is quite intense, because we do it very quickly, and most of the time we put in or add in excess titrant into the analyte. Compare this volume with the actual volumes. knowing that it is 24.75 or less than that. Okay, so this girl, this student, knows that she has enough, okay, or maybe she just refill the burette up until the estimated volume that she needs. Yeah, so she did really look at the final reading 24.95. She did not really add or refill NaOH because she knows she has enough. Yeah, enough to obtain the endpoint. Yeah. Now, look at the volume of NaOH used for the actual reading. It is less. Should be less. Yeah, because this one, the color of the endpoint was intense pink. So it needs to be less than that because when it is really pink, that means it is already basic. Yeah, not neutral anymore. Okay, 24.60, 24.4, and 24.3. So you see, these numbers are in the right trend. Decreasing volumes every time, which means each time the technique gets better. Yeah, the technique and the color of the endpoint should get better. Now, look at the burette readings. The burette readings are recorded to 2 decimal places. And look at the last number. The last number is either 5 or 0 only. Yeah, 5 or 0 only. I think I have explained this last week. Okay, kenapa? Why 5 and 0 only? Nothing in between. We don't have 24.77. No. Yeah, that is for the volume. And how do we calculate the average volume of NaOH? We only consider reading number 1, reading number 2, and reading number 3. We don't include the gross reading because it's gross. Yeah, it's just an estimate, not the accurate volumes. So we have 24.60 plus 24.40 plus 24.30 over 3 milliliters, and you calculate what you get. Alright? The next part is, you knowing the volume of NaOH used, we can now determine the molarity. Now remember, in the titration, the NaOH was the titrant and oxalic acid was the analyte. Yeah, titrant and analyte. From the volumetric flask, we took only 25 ml of oxalic acid. Only 25 ml, not the whole bottle per titration. And NaOH, okay, you can refer to the average volume used. Right? Now, this is the chemical equation. It is given in your manual. Oxalic acid reacts with 2 moles of sodium hydroxide to give you sodium oxalate and H2O. Okay, what we are interested in is the mole ratio between oxalic acid and sodium hydroxide. As we can see here, the mole ratio is 1 mole of oxalic acid reacts with 2 moles of NaOH. Alright? Okay, now, to calculate, remember from the formula, molarity equals to the number of mole of solute over, say that it is oxalic acid, over the volume of solution. Rearranging this formula gives you N equals to M times V. So this is what I have here. right? Molarity of oxalic acid times the volume of oxalic acid equals to the number of mole. And if you look down here, molarity of NaOH times the volume of sodium hydroxide, of course, that equals to the number of mole of NaOH, which is just the mole ratio, as we can see here, oxalic acid 1 and NaOH 2. Now, do we know the molarity of oxalic acid? Do we know this? Yes, we obtained this in part A. Do we know the volume of oxalic acid used? Yes, we used 25 ml of oxalic acid. Do we know the molarity of NaOH? This is what we want to calculate. And do we know the volume of NaOH that you have from the average volume that we have calculated before? Yeah. So that means we know this from part A. The volume of oxalic acid is 0.025, which means 25 ml. Molarity of NaOH, this is what we are trying to solve for. And volume of NaOH is around, okay, I don't know how you calculate the average volume. Yeah, 0.2443 maybe. Yeah, liters. Okay, I mentioned that the last number is either 0 or 5, but when we calculate the average, it can be any number, yeah, because it comes from the calculation, not from the reading itself. And knowing all this, you can always solve for the molarity of NaOH. I'm not going to show you every single calculation because this is already your second experiment. And look at the theoretical value. The theoretical value should be around 0.2000 molar. Similarly, for part C, knowing the concentration of NaOH, the exact concentration I mean, then you can now determine the concentration of HCl. This is from your part C, in which we titrate NaOH with HCl, vice versa. Now, as usual, just like before, the average volume should not include gross volume. That means we only consider 25.40 plus 25.30 plus 25.30, right, over 3, and that gives you the average volume of NaOH. Similar to part B, from the chemical equation, we can see that the mole ratio is 1 to 1. And hence, we can substitute our mole ratio down here. Okay, do we know the molarity of HCl? No, this is what we want to determine. We don't know this. Do we know the volume of HCl? Yes. Remember, we pipette 25 ml of the hydrochloric acid. So this is basically 0.025. Do we know the molarity of NaOH? Yes, we do. Yeah, we obtain this from part B. And do we know the volume of NaOH that we use? Of course, this is from the average volume calculated just now. And that will give you finally the molarity of HCl. Of course, it must be expressed in at least 4 decimal places of 4 significant figures, because we want, by standardizing, that means we want the accurate molarity. And similar to NaOH, the theoretical value is 0.2000 molar. Finally, what do you write for your discussion, or how do you write the discussion? Of course, you compare theoretical value with experimental value. For example, in part B, you obtain 0.1980 maybe, but the theoretical value is 0.2000. So one example will be something like the experimental molarity of NaOH obtained was 0.1980 molar, which is slightly lower than the theoretical value, which is 0.2000 molar. That is one example. The sentences doesn't matter. I mean, the way you write your sentences doesn't matter, as long as you convey the same message. Right? And provide the source of errors and how to overcome these errors if this is repeated next time. So you report, and you suggest, how to make it better. Number 1, this is always the major error done every time by students, that is inaccurate endpoint. Why? Because maybe students cannot control the stopcock, in the right way. Hence, the titrant was dispensed too quickly. And of course, you added excess titrant, which is more than the endpoint. And how do you know that? From the color of the endpoint. Endpoint should be a very pale pink. But believe me, to obtain a very pale pink needs skills. Needs skills. You need to practice, then you know how to be extra careful towards the endpoint. How to overcome this? Normally, you titrate slowly, drop by drop. 1 drop stop and rinse the inner wall of the conical flask. Then dispense another drop, stop and rinse. That is how careful you must be. Okay, so titrate drop by drop, very slowly upon reaching the endpoint. Okay, number 2, maybe this is my suggestion. Some of you might stir the oxalic acid quite fast, and that might have splattered the oxalic acid solute. So how to prevent this from happening? Okay, suggestion. You stir stir slowly and carefully. Slowly and carefully to avoid splattering. And of course, when it comes to quantitative experiment like titration, parallax error also contributes to the discrepancy, to the difference in the molarity, especially when taking the reading of the burette, when pipetting, and how do you prevent that? How do you avoid making that error? Make sure, the meniscus of the solution is at eye level, the same level as your eye, to avoid parallax error. And of course, if you have other ideas, other things that you think might have contributed to the error, you can add to your discussion. And if there are exercise questions given in the lab manual, include that as part of your discussion as well. Right? And finally, in order to write the conclusion, I believe there are 3 objectives. refer to the objectives or learning outcomes, and there should be only, if there are three objectives, maybe three conclusions depending on the objective. Say that the question, the objective needs you to obtain, to determine the molarity of hydrochloric acid solution. So the conclusion for that is the molarity of hydrochloric acid solution determined was 0.1975 molar. Maybe that's it. Don't add extra information to your conclusion. Alright, so I think that should be enough for you to complete your report. All the best.